Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to listen to it later on. Following today's event, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speakers, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your questions, and we'll get to as many as we can before the end of today's webinar. And also at the end of today's webinar, we will be doing a drawing for 3 $50 Amazon gift cards. So please stick around. Hopefully you'll be one of our 3 lucky winners. Okay, with that, we'll go ahead and kick off today's webinar, which is end-to-end automation with OpenShift and Instana. Our speakers today are Justin Pittman, who is a senior solutions architect with Red Hat, and Steve Waterworth, who is technical marketing at Instana. Welcome, gentlemen. Thank you very much for joining me today. Justin, I know you are kicking off the conversation, so I'm just going to verbally turn it over to you and put myself on mute.
Thank you, Charlene. Can you folks hear my voice? Just want to do an audio check.
Yep, we can hear you.
Thank you. As Charlene said, thank you for everyone for joining today. I am from Red Hat, one of our solutions architects that focuses on our container platform. And we are very happy to be on this webinar with Instana, one of our ISV partners. Next slide, please. The premise of today's conversation starts with the assumption that you want to try out containers, some Docker runtimes, or Kubernetes. And the question that gets begged here is, how do you accomplish that? What are your goals, and how can you attain those goals? Next slide, please. So given that premise, there is some context here. I like to share Kelsey Hightower's tweet from, well, it's now 3 years ago, which seems like a very long time in the software industry. And the point that he was making, if you're not familiar with Kelsey, he works at Google. Google open sourced Kubernetes. We started immediately contributing with them on Kubernetes. The point that he was making in generating the hard way, how to do Kubernetes the hard way, was that when people talk about Kubernetes, that is really just the beginning. Your applications and your workloads do not necessarily directly benefit from all of the constructs within Kubernetes. It's an excellent foundation, but that's what it is. It's a foundation. The real value comes at how to get that foundation working for your own workloads. That's the goal. So we want to figure out how to get you to that goal. Next slide. The challenges today with adopting containers, Kubernetes, any orchestration engine is choice. There is a plethora of choice because of this wonderful thing called open source, where there's a community of developers. This particular eye chart is not meant for you to figure out every logo in it. It's meant to say this is just a subset of projects sponsored by the Cloud Native Compute Foundation, which is where Kubernetes as a project, as an open source project, sits within that foundation. And there's a plethora of choice for you to build out the foundation and all the building blocks that your applications will need. If you go to the Cloud Native Compute Foundation website, you'll see options for networking, options for operating systems, options for CI/CD pipelines, for logging aggregation, for eventing and metrics. The choices are excellent. We benefit from those, but that also is a challenge because you really need to get to a point where you can run your applications. Next slide. We immediately talk about the customers here that have chosen Red Hat solution because the emphasis here is there is a value. Many of these customers that you see on the screen saw the value that Red Hat brings in making an opinionated platform for their workloads. These customers have applications deployed onto Red Hat's container platform called OpenShift. And the value of that is they took all of the different choices and options that they had, and they focused on Red Hat can deliver the platform that their applications will run on. That's what this is meant to say. Next slide. I want to introduce Mike Waite for this slide. He's the director of our product marketing for our ISV partners, because I think it would be very valuable for you in attendance to hear from him on the partners that we have working with our OpenShift integration. Mike?
Hey, thanks, Steve. Hi, everyone. My name is Michael Waite. I work here at Red Hat. I've been at Red Hat for 18 years. And for the 18 years, actually, as of February 10th of this month, so for the 18 years, my team has had pretty much the same goal, which is to work with software partners, database vendors, APM vendors, security vendors, for the sole purpose of making sure that our customers have certified software that runs on the Red Hat portfolio. It used to be just Linux when we were one-trick pony. We added JBoss. We now have storage and OpenStack and OpenShift. And I just wanted to chime in on this one slide and say we are investing heavily on behalf of our customers to make sure that all the software that you want to run inside your infrastructure, whether it's in the data center and multi-cloud, hybrid cloud, public cloud, has been tested and certified. If anybody wants to reach out to us and say, hey, I've got this application I want you guys to certify on OpenShift so we can make sure we have the best day two, operation support, please send me an email. My email address is waite@redhat.com. It's just WAITE @redhat.com, and we'll work with any software vendor if you folks tell us to. Thanks. Back over to you, Steve. Appreciate it.
Thank you, Mike. And right in the middle, just to wrap this up for today's webinar, you'll see that Instana is listed as one of the certified ISVs integrated with OpenShift. Next slide. Let's get back to the technology. That's probably what you all are here to see. Steve has an excellent demo lined up for you on Instana running on OpenShift. So what is the technology behind OpenShift? On the right is a very brief pancake diagram. It's not exhaustive, but it is meant to show that there's additional layers needed for a full platform. Yes, Kubernetes is in the middle. Yes, there are container runtimes included, but there are additional features and functionality that we include in OpenShift because that's what the customers said that they needed. For example, a hosted container image registry. That is included because we expect that your workloads may have some private or sensitive, or you may just want full control over the containers. You need a hosted registry that you control inside the platform. You can't always expect to go out to an externally hosted container registry. That's included. What's often overlooked are details such as a networking layer. That's kind of assume that you will provide a networking layer, but which one? Is it going to be Flannel, Calico? Which one are you going to choose? That's included in OpenShift as an SDN. And the SDN allows you to Mike's point, deploy to multiple different platforms. You can still deploy to AWS. You can still deploy to bare metal. And that's what we're highlighting at the very bottom of this pancake diagram. At Red Hat, we believe it is critical for you to be able to run your workloads where you choose. And so many of our customers choose to indeed run them in AWS. Some run them in Azure. Many run them on virtualization, such as VMware or Rev. A lot run them also on bare metal. You should have that flexibility. You should not be told by your vendor, well, you have to run it in this particular environment. We want to provide you that flexibility to run, and that requires certifying and testing on all those different platforms. So OpenShift itself is many things. We haven't delved into all of them, but it includes things like testing on different multiple platforms you can run where you choose. It includes something like an operating system that gets maintained. It includes a networking stack, and yes, indeed, it does include Kubernetes and a hosted container registry, etc. Next slide. If we didn't pound on this enough, the question on this slide is the non-technical. We just talked about what is OpenShift technically at a high level, but there are non-technical value items here. Many folks may not realize that Red Hat and Google started working on Kubernetes 5 years ago. And that's a long time in the software industry. And what we've done is we've made sure that there are staff in place, like our support staff globally, to be able to facilitate supporting long-term all the enhancements that are coming upstream. So yes, we contribute upstream, and we're the #2 contributor upstream to Kubernetes, just behind Google. But we also need to support you long-term. When we say long-term, we expect that you will need this platform for many years. We're 5 years into this already, and we still support those customers that started with us 5 years ago, and we will continue to support you. Next slide. So this is going to wrap up our section on Red Hat. We encourage you to evaluate it. There are 2 options I want to encourage you to go and try out OpenShift. If you are more of the ops persona and you want to run a cluster, let's say in AWS, go to our website, try.openshift.com. You can spin up a 60-day trial of OpenShift as a cluster in the provider of your choice, the platform of your choice. However, if you're a developer, you want to run OpenShift on your laptop, and you want to run it alongside VS Code or Eclipse or something to start building your applications with OpenShift, I encourage you to go to our developers.redhat.com website. You can download an all-in-one OpenShift VM that you can run on your laptop locally. So please go out and try it, make your own evaluations, and to Mike's point, give us a shout out if you see us out and about. Okay, Steve, I'm going to hand it over to you.
Thanks, Justin. So we've looked at the background of OpenShift, so let's get a little more technical and we'll get a little hands-on with it. But first, a little bit about Sanus. So yep, everybody has a customer slide. This is one of ours. So yeah, we already have a broad range of customers across many different verticals, and we have approximately about 10% of our customers are running OpenShift as opposed to just vanilla Kubernetes. So why do they do this? Well, in 2019, the DORA State of DevOps report basically said the faster that you can get new features and fixes out of the door, that's going to have a direct impact on the performance of the business. So really the goal is to build better software faster. And in order to do that, companies have adopted technologies and techniques like microservices, containers, orchestration, the OpenShift engine there, CI/CD, service meshes, in order to speed up that delivery. With speeding up that delivery, because as you change things and the faster you change things, the more risk there is that something could go horribly wrong. So you really need monitoring. Without that controlling feedback that the monitoring is giving you about the quality of the software you're delivering, things could get unstable very quickly. So you may hear in the press, and certainly the buzzword at the moment is observability. So what is observability? Well, that's the application components making things available, such as metrics, logs, and traces. So this is the data that's available from the running apps and from those running components, such as caches and data stores. And then the monitoring consumes that data, performs anomaly detection, root cause analysis, and alerting, lets you know when something's not quite right. So that's really what the core of monitoring is. And Stana, of course, does that, but it does a whole lot more as well. So with traditional observability, it's going to require you to modify your code, to include additional libraries and put in instrumentation statements around common frameworks. And Stana does this for you automatically. You just take your container, deploy it as you've done before. That will be automatically detected and the appropriate sensor loaded, and we'll start monitoring it straight away. So that really aids that speed in that you can throw the new features and fixes out there as quickly as possible, and you haven't got to go through that manual setting up of the monitoring. Then we have pipeline feedback. So as you're making those changes, you want to know that what you've just changed really, that it worked, that it improved things. It certainly didn't make things any worse. So Instana is collecting metrics at a 1-second granularity, and it is tracing every single request. And all that data is available within a few seconds of capture. So when you make a change, you know then straight away with minimal delay whether it was good, bad, or indifferent. And then the context guide helps you understand how everything fits together. So as you appreciate, once you get into microservices, you have a large number, hundreds, possibly thousands of these tiny little services all interacting and all running. And it goes OpenShift, being a Kubernetes engine, it just schedules the work where there happens to be capacity. So it's that idea of an app being tied to a host, that no longer exists. So to try and understand how everything's interrelated, that problem becomes many-fold more complex. So what Instana is doing is constantly learning what's talking to what and where it's running. So we know that then at any point in time, we can understand where it was running, what it was talking to, and what any impact was. And that really then drives that root cause analysis. So if you imagine a whole bunch of connected services, if you have a problem with a downstream data store, it's going to have that problem is then going to ripple upstream. So you start with one little problem and that ripples upstream and you end up with like 200 alerts. You need to be able to manage that, and that's really what the automatic root cause analysis does. It uses the context guide to understand the cause and effect, and then it'll give you that information and say, hey, this is your problem, it's causing all these other problems, go fix this first. And then application perspective. So you've got this, again, you've got this huge, complex, horrible, massive microservices, hundreds of different services. And of course, part of that Agile philosophy is quite often called the two-pizza team. So the software teams are most efficient when you can feed them with a couple of pizzas. So you've got like 10, 12 people in it. So each team isn't working obviously on the entire application, it's working on a subset of services within that application. So application perspectives allows each team to have their own unique view into the application as a whole, really reducing the signal to noise ratio for them so they can focus on what's important to them. And finally, unbounded analytics. This, as I said, we trace every single request. So this allows you then, or allows the programmers to look at those traces and slice and dice and filter them in any way they want to really get down to that nitty gritty and do any of those fixes or optimizations that are required. We'll be looking at some of this in the demo, not all of it, we don't have time, but we'll certainly hit on some of these cases in the demo. So how does it work? Well, there's an agent involved. That agent needs to get installed on OpenShift. We have an operator for that to manually install the operator. There's a few simple steps to do that. If you're already on OpenShift 4, then you'll have the Operator Lifecycle Manager included within that. So you don't need to set that up. You can just go straight off Operator Hub and install the Instana operator, then edit the Instana agent definition, and away you go. And with the operator, a lot of that complexity is abstracted from you so that the YAML for the Instana agent is considerably simplified because all that complexity is in the operator. So this is a template file for configuring the Instana agent, and you'll have things like the agent key and the endpoint as part of your install. And that can either be SaaS, we'll run the backend for you, or if you're security paranoid, then you can run it yourself, either on bare metal or in the cloud provider of your choice. So the operators certainly reduce complexity significantly. If you look at that handful of the YAML lines there to deploy the agent versus the full-blown YAML, if you were doing it entirely manual, runs to many pages. So that's definitely making life a lot easier with operators. So let's just see that in action now. So I'm going to go through a little scenario here. We've got an application deployed on OpenShift. We're going to take a look at that, and we're going to look at some of the automation that OpenShift offers, along with the automation that Instana offers, and try and show you a very simple scenario of getting a feature and a fix out the door as quickly as possible. So here we have the OpenShift web console, and we have this concept of build. So this is a level of automation that OpenShift provides on top of Kubernetes. Native Kubernetes doesn't have this. And if you'll notice over here on the source, we've tied these builds directly to our source in GitHub. So OpenShift then is going to pull the source from GitHub, run the build, create the deployment from that, create the service off that, and basically get your little application up and running with the minimum amount of effort. And actually all that can be created with just a single line. So those of you that don't like editing out YAML, myself included, this is a huge gain in automation and reduction in effort. So these are the various builds, and then that ends up in a set of deployments. And then here we have our various microservices that make up our application, all deployed and running. And if we take a look at one of those, then we can see we've got a couple of builds. This is the latest one that's running. And Justin was talking about the image catalog, so the image registry rather. So that's the image that's hosted inside OpenShift, and yeah, it's in sync with the master branch in our GitHub repo. So we flick over to Instana, and we're looking at the Kubernetes top level tab here, and we can see that that OpenShift is a first-class citizen in Instana, and that it's a top-level entity. And looking at that cluster, we get our cluster overview about what's running, what resources are there. We have a number of namespaces, so our app is running in the Robot Shop namespace, and we can drill into that namespace. We see our details about that namespace, what we've got running, and notice we don't have any deployments. That's a Kubernetes thing. In OpenShift, it's deployment configs, and yes, we have a bunch of deployment configs. We'll be delving into those in a moment. We can get things like the details, so any tags, labels, annotations, they're all in there. All that metadata also is indexed and fully searchable. We'll be looking at that a bit later. So let's look at our deployment configs. We've got a bunch of those. So these are all the various component parts of our application, and drilling into one of those. Again, as we drill down, we're just getting more and more detail. So we've got our detail of our deployment config there. And that, of course, is running pod, and looking at the pod has some containers in it, and we have our container running here. So we're now drilling further and further down. So we're looking then now down at the Docker container info, and we're getting all our time series metrics around that. And that Docker container is actually running a Node.js application. So we can go even deeper, and now we're into the instrumentation from that Node.js application. We're looking at the runtime information here about the Node.js runtime. And you'll notice if we look at the breadcrumbs here at the top, and Stan, as I said, it maintains that map of what's connected to what's running where. So we can see that, in fact, it's a node running in a Docker container in a pod on a host on a cluster. So all that relationship is maintained. So at this point, we now make that leap, and we're going from looking at infrastructure. So we've been looking at everything that makes this little application run. And now if we look at the catalog service, we now see basically the code running. So this is the catalog service. This is a result of all that trace data. So as the traces come in, the data is analyzed, and this gives us our KPIs. We have our rate, errors, and duration KPIs. This service has a number of endpoints. These, again, are all automatically discovered, and we get our KPIs for each endpoint. So we see our rates, errors, and duration there as well. Notice that we have our link back then to the Kubernetes or OpenShift service. So we're going now back from the logical world back to the physical world, and we're looking at the catalog service, which is sort of where we started this little journey. So everything's connected, everything's interlinked. All that relationship information is maintained and easily navigable. So we've got to have a little look at the events. So this is probably where, on a day-to-day, your ops guy is going to spend most of their time looking at any events that are generated, and we're having a problem with one of the services. We've got a very high error rate. So we can see when it was triggered. We'll drill into the actual service itself. So we're looking at a different service now. And again, we've got that link back into the Kubernetes or OpenShift world. And indeed, yes, it does have quite a high error rate. Performance isn't bad. We look at the latency, it's erroring and erroring quickly, but yeah, the error rate's pretty high. Some requests are going through okay, some not so good. So yeah, about 50% of the requests that are going through are resulting in an error. As part of that instrumentation, the common logging frameworks are instrumented. So we're going to capture any error messages at warn or above. So let's hope that the programmer actually put some sort of error handling in there and some logging. So let's have a little look at the log messages. And indeed, we can see we've got a fairly regular stream of this particular error message. So drilling into this then gives me a view of all the traces where this error message occurred. And we trace every single request. So these are all the instances of this error. Looking at one of these, I can now delve in deeper and find out what went wrong in this request. So we have our request. It's a post to this URL. It arrived. It made a subcall here. So it called off to a different system. It's called off to the user service, and that returned okay. That was good. The user service made a call to a data store. So again, that all came back. That was good. And the error is indicating is happening here after these, because this little diamond indicates at what point the error was thrown. So we go back up to the top here. Yeah, we got a 500. So it was a pretty serious error. It wasn't really expected. And if we expand the error details here, we get our full stack, and we get a view here, and then this is our source. So we can go and take a little look, and in fact, it was a generic error handler grabbed it, so it wasn't in a try-catch block, so this is probably an unexpected error. We know that it happened inside this routine from the trace. following it through. We know that the call off to the user service, that was successful. It came back, and then it blew up round about here. And in fact, the comments in the code give the game away a bit, but this is of course a demo scenario. So we know there's a bit of a problem around here. So let's see if we can't fix that and then double check that the fix worked. So I'll just reset that back to the top here. Hopefully we'll see a lot less errors very shortly. And if I hop over to my editor, here's the line in the source. And as any good programmer knows, what we should do is put in a default value so we don't get a none. So well, the default will be an empty array. And save that over to my terminal. And if I add that in and do a quick commit, and then push that up to the repo. So I've now made my code change, pushed it into the repo. So that's sitting there ready. If I go back to my OpenShift console, go to my builds, it's the payment service we're looking at, and I can fire that build off. Now I'm choosing to do this manually for the purposes of the demonstration, but of course we could put in a webhook in there and have a build triggered automatically as a result of that push into Git. There's various levels of automation you can choose to do. So that's going to build away. Hopefully it should take about 30 seconds, so it should finish any moment now. Hey, as if by magic, you'd think I'd planned this. So that build has now completed. I can take a look at the build log and we can see, yep, it's cloned the repo, pulled it down. It then runs the Docker file and builds up our Python application at this point. And then there's a post commit hook, which then does our integration, and that loads some utils, fires off the pipeline message, and then OpenShift pushes that into its registry so the image is available. If we take a look then at our deployments, we have our payment deployment. There's our latest version 6, which we're now running. Taking a look at that, we can see, yep, that's up, running. We can have a quick look at the logs. It's now processing data. That's ticking away quite nicely. Back up to the top there. And if we look at the details, you can see, yep, there's my commit message, and there's actually a link back into the GitHub repo. And yep, my name, I did the change. So all that gets tagged in. So all that's done for you as part of the automation. If we go back to Instana now, so the release has occurred. So we've got a release came through, and we see it's payment build 6 with the commit message, fixed it. And we're starting to, and that marker also appears on the timeline. So let's zoom in a bit, go down to say a 10-minute granularity. And now we can see very quickly, there's our change, and after the change, no errors. Yeah, no errors. So that's very quickly shown then that we get that immediate feedback. We made that code change, pushed it, did the build. We've got an indication on the timeline that a new deployment happened. Instana just detected that, found the new container, went, hey, look, I've got a new container, started monitoring it, started tracing it. Data comes through very quickly with pretty much zero lag, and we've got that real-time data coming through. So we're getting that immediate feedback that means, okay, good, I can sign this off now. This change worked. I can crack on and get on working down that backlog of other features and fixes that need to be done. So that sort of shows that bit of automation tying up there with both OpenShift and Instana. So if we just go back to my little presentation. So in summary, We did that automatic detection and monitoring of components as they're deployed or scaled to get those 1 second resolution on the metrics, every single request traced, and we get all that information back pretty much in real time, just a few seconds behind real time. And with that high level of data, the high density of data, it really means you can push forward, deliver better software faster with the automation that OpenShift provides you and the high density data that Instana provides you. That pretty much ends the presentation. We're open for questions. I'm hoping some people typed in furiously some good questions as we were going through this, and we can get into that Q&A section now.
Awesome. Yes, if you have a question for either of our speakers, please go ahead and use your GoToWebinar control panel and submit it, and we will get to as many questions as we can. Let's see, the first question here is, how many technologies does the Instana support?
So Instana supports over 100 different technologies. Don't ask me to list them all because I can't remember every single one of them. So there's a large number of language runtimes and then various caches, data stores, web servers, etc. You can go to our website, instana.com, and there's a supported technologies section.
Okay, great. Next question, why is granularity of 1 second important? Isn't anything less than, say, 1 minute good enough?
Well, with containerized workloads, things can come and go very quickly. So we were looking at long-running services, but equally you can have little batch jobs and cron jobs in a Kubernetes OpenShift environment that can come and go very quickly. So they could conceivably spring up, do their piece of work, and shut down again in less than a minute. And if you've only got 1 minute granularity of data, you're going to miss that entirely. And equally, when it comes to doing changes, if you're not tracing every single request and have high resolution, say 1 second granularity data, then you do that change, and if they take the worst case scenario, you push a change out and it's terrible. It causes loads of errors, so your customers are going to see that and they're going to have a really bad experience. And you're not going to know straight away. You're going to have to wait a minute or so for the data to come in, but at which point you've only got 1 data point. So you're probably going to say, well, is that data point valid? You know, it's only 1 data point. Is that enough to make a decision on? Maybe I should wait a little longer for another data point. Oh, now we're at 2 minutes. Oh, that's still maybe not enough data. So you're going to be sort of 10, 15 minutes before you've got enough data to make the decision to say, actually, that's a terrible release. What we need to do is roll that straight back. By which point you've had a terrible release out there, published live for 15, 20 minutes. It's not good.
Right, okay.
That's why high resolution data is really, really important in highly complex and rapidly changing containerized environments.
All right, makes a whole lot of sense to me. Okay, next question. What does Instana consider an application to be? And what is an application perspective?
So an application perspective is just a different view on all the data. So an application can be anything you want it to be. So an application perspective could be, say, just a particular namespace, or it could just be 2 or 3 services within that namespace, or 2 or 3 services across all namespaces. It's however you want to slice and dice that data. So an application means different things to different people, hence application perspectives allows very easily for you to create those different views. So yeah, depending on, you might be a developer on the payment gateway. So your idea of an application is the payment gateway. Somebody else might be a front-end developer, so their application is sort of the web server and the web pages. Yeah, different things mean to different people. So like someone who's more interested in data stores, their application is maybe a bunch of MongoDB instances across multiple namespaces. That's why we created application perspectives. There isn't really a fixed term. It really depends what you want it to be.
Okay, all right, great. Plenty of time for questions, guys. So if you do have one, please go ahead and submit it using the GoToWebinar control panel. Our next question here, do you have any plans to support 3-scale monitoring?
Not entirely sure what you mean by 3-scale monitoring.
Okay, so
Whoever
Miguel,
asked that, can you
yeah.
please provide a little more detail around that?
Yes, Miguel, go ahead and just use just put it right in the questions box, and we'll circle back on that one. So then we'll move on to this one. Does Instana provide the alerting via email regarding issues?
Yeah, so there's a bunch of integrations for sending the notifications out. Email is one of them, Slack's another one, PagerDuty, VictorOps. Yeah, I'm running, there's more, but I'm running out of memory at this point. Yeah, there's a bunch of ways of getting those alerts out there.
All right, great. So Miguel did circle back. He said Red Hat's 3-scale technology.
Okay, so Red Hat's 3-scale, which we call application API APM, application management. The terminology has gotten a little changed there. So not sure exactly at what level of monitoring you're asking for. I think it's a good question though. So what Instana is providing and what Steve showed is a level of detail. For example, the cache in memory, or JVM GC garbage collection, or the amount of calls and requests. It is true that 3-scale can do API metering, where you're governing how many calls can be made. But to Steve's point earlier, the Instana solution is getting a bit deeper and granular about being able to provide more metrics than what is provided by OpenShift out of the box.
Thank you,
All
Justin.
right. Excellent. Okay, let's see. Next question. Is Instana mobile friendly?
Yeah, so it's a web UI, as you saw. It works okay-ish on a mobile device. There is plans. I'm not going to give any timescale, but there is plans for a mobile app, which will obviously give you a much better user experience consuming the UI on mobile, and mobile friendly the other way. If you want to monitor your mobile app, then yes, we do that. We have end user monitoring for mobile applications.
Okay, great. Let's see. Next question, but just before I ask, just want to remind the audience, we still have lots of time, guys. So please don't wait. If you got a question, go ahead and get it on in. The next question: does it provide configure? Let's see. Does it provide to configure customized monitoring rules based on business rules, which will help support the development team?
Yeah, so Instana has a core set of rules. We call it the curated knowledge base. So for all the technologies we support, we have a bunch of built-in health signatures. So all the basic stuff like your JVM GC is too high, you're running out of disk space, all that is already in there, and that gets you covered straight away. But of course, there's those unique things to your particular environment and sort of business rules as well, more business-driven health metrics. Yeah, so you can create your own custom ones on top of those. So if you've got so I don't know, in your environment, if a particular queue gets deeper than 5, all hell breaks loose, and you want to know, well, then you can create a custom rule for that. Any of the metrics that are in there, yep, you can select and create custom rules for those. And those, as well as the basic thresholds, if X is greater than Y, we have other detectors in there. So we have detectors, for example, sudden change in. So if you get, so a good example, one of the standard one that's built in is a sudden increase in latency. So where you get a big jump in latency on a service or an endpoint, that's going to trigger. So you can use those built-in detectors in your custom rules as well.
All right, great. Let's see. Gosh, so many good questions coming in. Can you explain the workflow for building and deploying of applications into OpenShift and how the logs are integrated with Instana?
I'll start on that, and then I probably have to hand it to Steve for the latter half of that question. So the first half of that question. Yep. Can you hear me?
Yeah, fire away. Go ahead.
Okay. I wanted to make sure. So the first part of the question, in OpenShift, your application can be built from a variety of different ways. Steve showed integration with GitHub, where we can literally pull down source code, and we have builder images to do that. A little bit different if you're coming from Kubernetes, you are probably familiar with builds and deployments, but OpenShift has what are called build configs and deployment configs, which provide a bit more hooks and triggers and integration, like with the hosted image registry. So you can build your application from source or from binary or from Docker image. Now, OpenShift does include a logging aggregation solution. That solution is built upon FluentD at the pods, and then all of that gets aggregated back into Elasticsearch and displayed to you through Kibana. But again, that's the default kind of consumption of your own application logs. We don't get into a lot of details about customization, or if you're trying to do some on-the-fly tracing while problems are happening. So I'll pass it back to Steve to maybe answer the latter half of Craig's question.
Yeah, so as Justin mentioned, in a Kubernetes OpenShift type environment, FluentD's probably the most popular log shipper. So we don't do logging ourselves. There's already like 101 different solutions out there for logging. We're more concentrated around the metrics and the traces. So we integrate in with a bunch of popular log aggregations. So we've already mentioned Elk, the Elasticsearch Kibana solution. Yeah, we have an integration into Elk. We have an integration into Humio, into LogDNA and CoreLogic, and of course Splunk. Yeah, so that pretty much covers everybody. So we can go from the Instana UI in context into the logging UI. And then coming soonish with the code instrumentation, you'll be able to put the trace ID, the current trace ID, into the log message. So therefore, in your log aggregation, you'll be able to say, show me all the logs for this particular request.
Excellent. Okay. Lots of good stuff there. Okay, next question. Does Instana have an operator for the agent install?
Yes, it does. We showed that in the presentation. It's in the operator repository, so it makes it very easy to get the agent installed using that operator.
Perfect. All right, great. Here's another one for you. Is Instana available both on software as a service and on-site installations?
Yeah, so the default, and I would think the easiest is just to consume it as SaaS. So we'll run the back end for you. It takes all the pain and agony out of running that. And of course, you get all the updates all done for you. However, if you are a little security paranoid, then there is an on-prem install as well, which you can put on your own bare metal in your data center or in a VPC in one of the various cloud providers. All that is fully supported, and our engineering team will support you in that. But of course, you've got to do more of the lift and shift, and you've got to manage the updates and the backup of that. But yeah, all fully supported, and it's the same price whether you're SaaS or on-premise.
All right, great. Doing a quick time check here. We're about 10 minutes to the top of the hour. We do have time for a couple more questions, so any stragglers, feel free to go ahead and submit those questions. Here's another one for you. How is Instana different from all the other APM providers out there, like AppDynamics or Dynatrace or so forth?
Well, I would say we're cloud native. So if you look at when the other solutions were written, that's sort of before the whole containers and Kubernetes thing happened. They've got certain legacy baggage with them. They were written more for the SOA type environment as opposed to the containerized microservices and orchestrator environment. So we're a much newer solution, and our engineers explicitly targeted that the problems and the challenges associated with running microservices and containers in an orchestrated environment. So if you look at how easy it is, for example, to get the agent installed, it's a one-liner to get the agent in there. We got that high resolution data. We trace everything. Kubernetes, OpenShift, containers are all first level entities for us. So yeah, we're much more a cloud native monitoring solution. We don't have that legacy baggage, but that doesn't preclude us working with those legacy solutions. In fact, many of our customers are on that journey to microservices and containers and OpenShift. So we can still monitor their legacy apps. That's actually quite easy. And then validate the performance, and then as bits of functionality are chipped off and made into microservices, we can continue to validate the performance and that everything still works as you migrate into a microservices and containers and OpenShift type environment.
Excellent. Okay. All right. Let's see. One more question here for you. What is the pricing model for Instana?
So the pricing model is in a Kubernetes type environment is per worker node, so or minion. So however many nodes you have, then that's the pricing model. So no nasty counting cores and memories and all this sort of thing. Just how many nodes have you got, and then it's priced per node. And then then obviously as you scale up, then there's the bulk discounts kick in for volume on the number of nodes, and then also for however long you sign up. The default is 12 months, but if you choose to sign for 24 or 36 months, then there's also some sliding discount rules that kick in there as well.
Excellent. Okay. Well, that looks to be all of the questions that we have. So I'm going to go ahead and close out the question and answer period. Thanks to everybody who did submit questions. Really, really good ones. Want to remind the audience that today's event has been recorded. So if you missed any or all of the event, or if you just want to listen to it again, you'll have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also living on the DevOps.com website. So you can always go find it there. Just go to DevOps.com/webinars and look in the on-demand section, and it should be right there waiting for you. And,
hey, this is Mike. Wait, can I jump in with one plug here real quick?
Go right ahead.
I'm still here. I've just been on mute. Anyways, if anyone wants to come talk to Red Hat about the certifications that we're doing with software vendors, we're going to be at KubeCon in Amsterdam. It starts Monday night, March 30th. You folks can come. Stop by the Red Hat booth and just ask for Mike. Everybody knows Mike Waite. I'm 6'9", which is over 2 meters for those of you who may be from Europe. And our friends from Instana will be there as well. So stop on by, talk to us, and if anyone has any questions or forgets about it, shoot me an email. It's waite@redhat.com, WAITE@redhat.com. Okay, thanks for letting me jump in there.
All right, no problem. Thank you, Mike. Appreciate it. Okay, so let's see, where am I? Okay, so before we go, I do want to do that drawing that we said at the top of the hour we'd be doing for the $350 Amazon gift cards. So without further ado, we'll go ahead and do that. Our first winner today is Sherry S. Congratulations, Sherry. Our next winner is Matt C. Congratulations, Matt. And our third winner today is Elena N. Congratulations, Elena. We'll be following up with all three of you offline via email to get your gift card over to you. And I guess that's pretty much about it. Please, if you do check out the webinar on DevOps.com, please take a look at some of the other webinars that we have, both upcoming and on demand. Hopefully there'll be one or two that pique your interest. Justin, Steve, and Mike, thanks so much for joining me today. I appreciate it. Such great information.
Thank you very much.
All right.
Thank you.
I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.